Hello, everyone. This is Dr. Marrero, Math Topics. Welcome to today's video. You can see the question on the board. You can see that question right there. And there are two ways to do it. You can use the procedure, the mathematics procedure that you learn in class by memory, or you can learn the procedure and the reason behind the procedure, the why behind the procedure. This is what I call knowing what I'm doing. There are two ways to teach. There are two ways to learn mathematics. One way is you go, sit down, the teacher explain, you learn the procedure, you see the same question or similar one in your assessment, you reproduce the procedure, you get the right answer, you pass the class. There is another approach that is learning lifetime. So I have a playlist in our channel that is called How Do I Teach Math? How Do I Learn Math? And I invite you to watch those videos. It's time, it's really the time that we change that. The first procedure. Because we are not learning math. And the student must know that, and we can have that conversation with the students. So you can survive probably the next assessment, but you are not going to survive a more sophisticated assessment because you are going to forget this in a couple of days. This is a conversation that I always have with my students. You learn lifetime, or you learn just to pass the class. So that's why I don't like sometimes to teach some assistance ideas in order to learn math, like pandas, for example, for the order of operations. And only say, for example, domain and range, that only you say is the x value. The domain is the x value. The range is the y value. You can go beyond and you can say the domain is the input and the range is the output. And you do not explore more than those sentences. I don't like that way. I like that you, the learner, or you, the teacher, or you, the math lover, when you explain math and when you're learning math, you learn the reason behind the procedure. That's why we have two different mathematics. We have the procedural mathematics, fluency in procedures, but also we have fluency in conceptual mathematics. And that is, you can apply that in every lesson, in every class. So pandas, or domain is the x, range is the y, and you do not establish all the connections behind those phrases. And that's why we cannot stop the trend throughout the years of a student failing math. And we can see better results in other countries. And we have to ask ourselves, why? Why we cannot have a population that learn mathematics like any other subject in an effective way. Not all peoples will be mathematicians. I agree with that. But we, the teacher, has the responsibility to teach with rigor, mathematics. Total rigor. And we had to move the population to understand math. We don't have to do the opposite. We don't have to do the inverse. To lower our teaching and to lower the standards of our science, of our subject, in order for the general population to understand. It's like you do not teach someone to appreciate a Picasso painting. And you say, no, don't look at that. Let's minimize what Picasso tried to say here, what techniques he was using. No, don't talk about that. Just learn how to identify the painting and who was the authors. Then, do you think that this is culture? Do you think that this is learning? No, this is not learning. This is not learning. In mathematics, happens the same. In every science, in every subject. And that's why it's important that in questions like this, a function, quadratic function, 2x squared plus 5x minus 3, and they said find the equation of the tangent line of f at the point where x is equal to 3. Of course, you can do it in a second if you know basic algebra. We're not talking about calculus here. But we are responsible to talk about calculus here. We are responsible to talk about what is a tangent line to a function and explore the dynamic between geometry, plane geometry, algebra, and calculus. And even physics. It's our responsibility to talk about that. Because this simple idea that you students in calculus that start working with those type of questions, they said, oh, I have to find the equation of a tangent line. So I need the slope. Because when I learned equations, lines, I learned y equals mx plus b, no? Or y minus y1 equals m times x minus x1, no? Different forms. But in all of them, we have, or the standard form, we have m. We have the slope, eh? We have the slope. So we need the slope and we need a point, eh? And we need a point. But this is procedures. So we had to move to visualizations. We have to move to visualizations. So we have to move to something like this. Try to describe with visuals the phrases, the words, that translation from words to something visual. And we are talking about the tangent line, and it's tangent because it's touching the curve at one point, and you can work with vocabulary here, and you can work with the word tangent, and you can use geometry, and you can use the own definition, what is tangent, touching only one point. But this is important, that conversation. This is a rigor in math teaching and a rigor in math learning, the equation of the tangent line. And this is the function. This is the function f. Okay, this is the function f. That curve is the function f. And I'm looking for the equation of this line. No. I want the equation of this line. Again, I need a slope, and again, I need a point. But what is that later on? Because if you are a teacher, a math teacher, and you teach with rigor, you know that slope of that tangent line to the curve is a rate. That slope is a rate, and that rate can be velocity. And the rate of the velocity can be the acceleration. And you are preparing the students to calculus. I don't know. In middle school, you can do that. But this is teaching with the rigor. Now we proceed. I haven't talked here about the procedure. I can go and I can use visualizations of the quadratic function here, the parabola. And I can talk about the y-intercept of that parabola, which is that constant over here. And I can talk about the opening of the parabola, which is that coefficient 2. And I can move the students to a graphing calculators, and they can see visually what is that 2x squared plus 5x minus 3. Translation of phrases and expressions into a visualization, into a visual idea. This is rigor. And we, unfortunately, because X reasons, Y reasons, we don't do that. And if we continue doing the same, the results will be the same. The students will not be learning lifetime. They will be learning the procedure to answer that question. Because you can direct the conversation to a procedure. You can guide the student to a procedure. But if you don't do that initially and you start a conversation and you guide the conversation through ideas, now you're teaching with rigor. And domain won't be any more X, and the range won't be any more Y. But relations. Relations. What kind of relation? I don't know. 1 value to the second power. 1 value times 2. 1 value times 3 plus 1. And we generate a conversation. A conversation that is not talking about domain and range, is talking about relations. It's a specific relation. It's a very specific relation between two groups. And when you teach number system, real numbers, natural numbers, I don't know, whole numbers, you teach groups. It's important that you teach groups. It's a group of numbers with certain characteristics. And when you use those kind of words throughout the student life in teaching, in learning mathematics, they start learning lifetime, because my elementary teacher told me about the group of natural numbers or a set of natural numbers, but I prefer a group. And then my middle school teacher is talking about the group of real numbers. And for me, the idea of a group is something that have a common characteristic, or they share common characteristics. And this is learning and teaching with rigor. And then, after you consolidate that, after you create the foundation of that, then is when you start moving the conversation to the procedure, to the reason why we need to find the equation of the tangent line. A tangent line, okay, I'm not talking about the derivative, which is the rate of change, which is the instantaneous velocity, the instantaneous rate of change. I'm just talking about, let's write that equation of the line. And notice that that line has a common point with the curve. Just one common point with the curve. But that line, if I put all the tangent line in a group, all the tangent lines in a group, okay, all the tangent lines in a group, I create what is later called slope fields in calculus. If I put all of those, we have to teach mathematics in a way that the students learn how to learn mathematics. And group is a word. It's an essential word. Let's put all these lines tangent to the curve at different points. Let's put those tangents in a group. And then put those tangents everywhere in a piece of paper, and you will be creating slope fields. And when they see a slope fields in calculus, they say, "Oh, it's a group of tangent lines to some curve that I don't see it, but it's a group of tangent lines." This is the conversation. This is the conversation, and I want to copy this and paste it right here. Okay. And now we can, let me put it smaller. And now we can answer the question here. Okay? We can answer the question. We can answer the question. We can create the equation of the line. We need the slope of the tangent line. How can we find that slope? Okay, in calculus we find the derivative of this function, which is 4x plus 5. This is a derivative. It's a function. It's another group of x and y's, another group of inputs and outputs, another relation. And if I want to know if I know the derivative definition, which is that the rate of change at that particular point, I just substitute here the x by 3. And I have 12 plus 5, which is 17. This is the slope. This is the slope. This is the slope of the tangent line of the function f. And I use the first derivative. I know the first derivative represents the rate. So that f prime is n. So how can I find it when at x equals 3? So substitute the x by 3. And you will see at the end the slope, the n. And now you have a point, no? You have the x of the point, but you need the relation with that 3. You need f of 3. Okay, you need the y. Because that intersection, remember the curve, that intersection between the tangent line and the curve is a common point for both. So I can replace the x right here by 3 in the original function. Simple as that. Okay. And I have here 2 times 9 plus 15 minus 3. This is 18 plus 15 minus 3. And 18 plus 15 33. That's it. Minus 3 is 30. So the point here is 3. Let me use a different color. 3 and 30. This is the point. So I have the point and I have the slope. And when the point and the slope, I can create the equation, no? I can put it over here. So y minus 30, okay, equal the slope 17 times x minus 3. And that's the equation of the line of the tangent line of f. Y minus 30 equals the slope 17, x minus 3. But when you write this to the students, y minus 30 equals 17 times x minus 3, let me double check. This is derivative. And this is a point that is common to f, is common to f, and is common to, it's a common point, and it's a common point to the line tangent to the curve. And this is the conversation that we have to have when we finish. Okay, what is that 330? Okay, this is a point, but it's a common point. Why is it a common point? It's a common point. Sorry, let me put the line right. I need a tangent line, like this. Tangent line. That point is common to the line and is common to the curve. The curve is f, that line is y minus 30. Equals 17 times x minus 3. This is rigor. And when we teach a slope, we have to teach that word too, derivative. This is the conversation. And this is what I want to discuss with you today in this series about how do I teach math, how do I learn math. And I hope you like it, and I hope you subscribe if this is your first time, and I hope that you enjoy math topics, and I hope that you are part of this learning community. Thank you for watching. See you in the next video. Rigor in math.